Hello. So in this lecture, we will learn another type of signal actually. Okay. So up to now, we have studies three classification of signals. Okay. The first one is random and deterministic. Deterministic. Okay. The second one is the continuous time and discrete time. The third one is non-periodic and periodic signals. Okay. So these type of signals we have learned. Okay. So now today we are going to learn about even and odd signal. Odd signal. So this is another classification. Okay. So let's see what are the even and odd signals. Okay. Even and odd signal. Okay. So this is our topic. Okay. So so before discussing this topic, before discussing this topic, uh, in future, okay, maybe next week, okay, we will learn another new topic. Okay, that is we called time transformation. Time transformation. Okay. So actually this is this cover one learning outcome, that is LO2. This is the learning outcome to time transformation. So here you are going to learn various time transformation techniques and their usage. Okay. Uh, so and also sometimes we call this time is a independent variable. No, that is an independent variable. So sometimes we call it independent variable transformation. Independent variable transformation. Okay, transformation. And also we are called is time manipulating. Sometimes we call time manipulating. So we are going to learn about time manipulating techniques. Okay, in our future class. Okay, so under this time transformation, we are learning about various time transformation. Okay. The first one is time reversal. Time reversal. And we are learning about time scaling, time shifting, so on. Okay, so there are many time manipulating techniques. Okay, so let's see what is this time reversal. Okay, so time reversal is nothing but if you have any signal xt, so you know that this t is the independent variable. So in your signal, there should be a t variable. No? For example, if it is a sine signal, sinusoidal signal, so it look like this sine omega naught t plus 5. So you can see that t is here. So time reversal is, instead of this t, we substitute minus t. That is time reversal. So this is time reversal actually. Instead of this t, we substitute minus t. That is time reversal. So we have a sine omega naught. Instead of this t, we have to use minus t because this is minus t. Now the variable is minus t. Minus t plus 5. Okay. So this is the time transformation. Okay. So you can get you can draw the graph for time transformation. So when you draw the graph after time reversal, okay, after doing this time reversal, you will get the image of the signal through this dependent axis, that is y-axis, image of the y-axis, image through the y-axis. For example, if you write this sine signal, so sine signal may be like this. Let's say it is starting from here, like this. So if you get the time reversal, this is xt. So if you get x minus t, so it will get the image. That means this act as a mirror. Okay, this y is act as a mirror. Right? So now it act is a mirror. Okay, so you can see the image here. So image will look like this, no? Like this. Okay, so this is the time transformation signal, time transformed signal, time reversed signal, time reversed signal. Okay, this one. Okay, so another example, if we have, let's say, the the xt is like this. Let's say the xt is like this, like this. This is the signal. So this is xt. So if you draw the x minus t, so it will get the exact image through this line. So you will get this kind of signal. So x minus t is look like this. Okay. So if you get this kind of signal, now this is t naught. So you will get exactly, so this is xt. So if you write x minus t, so it will look like, if the now the mirror is here, so it is like this. Here up to t naught, then here up to t1. So this is the time reverse signal. So I hope you can understand what is time reversed. So what we have to do is we have to get the mirror image. Okay, mirror image through y-axis. Okay, that is the time reverse signal. Okay, so that time reverse signal is actually related with odd and even signal. Okay, that is why I explain it first. Okay, so what is odd and even signal? Even and odd signal. So if we have xt, if we have a signal time domain signal xt, okay, if we get the time reverse signal and it is equal to again xt, okay, so time reverse signal x minus t is equal to xt, our original signal. So we call this even signal. Okay, and x minus t is equal to minus xt. So this is odd signal. This is even signal. This is odd signal. Okay, so please try to understand these two definitions. This is odd even signal. That means time reversal reverse signal is equal to again the signal. So x minus t, that is time reverse signal is equal to not xt reverse but minus xt. Okay. So how can we? So for example, okay. For example for even signal. Can you imagine? Example for even signal. Okay. Please try to image. So if you consider maybe this type of signal. Let's say this is t naught and this is minus t naught. This is xt. Okay. Okay. Please get the time reverse signal for this. Okay. So I'm now drawing the time reverse signal. Okay. I use another color. So please try to draw the time reverse signal. Now you should be able to write this. You should be able to draw this. Okay. So if you consider this section, 0 to t naught, what we have to get? We have to get the image of this section through this x-axis. Now this is the mirror. This is the mirror. So if you get the mirror image for this axis, for this section, it will like this. No, it will like this up to t naught. Let's say this is A. So A to t naught like this. Okay. Now please consider this section. This section. Okay. So if this is time reversed, you have to get again the time mirror image. That means again here it is here. Okay. If you get the mirror image, so it is applies this. So if I write the mirror image for this part, it will like this up to t naught. So what this is xt and what this is x minus t. So please look at this. The both signals are same, no? Both signals are same. So this is a even signal. This is a even signal. Okay. So you can see that xt is equal to x minus t. So this is a even signal. Okay. So any symmetric signals are all the symmetric signals are even signals actually. Okay. So if I get another example, symmetric with this y-axis, because if the signal is same across this y-axis, we call it symmetric. Okay. So that kind of signals are even signals. Okay. So if we consider another signal, okay, what happens if the signal is like this here and here? So this is also a symmetric signal. No? Let's say this is t naught t1. This is minus t naught minus t1. Okay. So this is xt. So if I get the time reverse signal x minus t, okay. So you will get, so you have to get the mirror image. So mirror image for this section, okay. Mirror image for this section, this one and this one, you will get. So now it is like here, no? So you will get this kind of mirror image up to minus t1. Okay. So if you get this section, again, if you consider this section, you will get the mirror image for this section from this side, no? So you will get this kind of mirror image, T naught, T1. Okay. So what is this? Again, xt is equal to x minus t. So this is also a even signal. Okay. So can you imagine any example for odd signal? Okay. So for example, so I'm sure maybe you should be able to at least guess this type of signals out. Okay. So say that we have this type of signal. So what is the mirror image of this? This one. So it is not equal, no? So it should be minus. That means minus means it's go to this side like this. So if you have this kind of signal, okay, let's say this is T naught and this is minus T naught. This is A and this is A. Okay, this is minus C. So this should be a, if this is xt and this is t. Okay, now I am going to draw the x minus t. So what is my x minus t? So we have to get the mirror image from this one. Okay, so what is the mirror image for this? So it is like this, no? For this section, mirror image for this section, it is like this. Okay. Now, what is the mirror image for this section? This section. Okay, for this section. So this is the mirror. So mirror image is somewhat like this now from here. So the mirror image will be, here it is A. So here is starting from A, it is go like this up to T naught. So this is the mirror image, x minus t. So you can see that xt is not equal to x minus t, no? Xt is not equal to x minus t. Okay. What if we get the minus x minus t? So I will get the minus x minus t here. I multiply x minus t by minus 1. So I will get minus x minus t. Okay. So what happened? This side. So this side will be minus value. No? So this a will be minus and the corresponding whole value will be minus. And this 0 will be 0. So you will get, if this is a, so you will get this kind of 1 up to t naught. So this is the minus xt, minus x minus t. Okay, this section. Okay, so what happened this section? So it is also multiplied by minus. So this minus value will be plus. Okay, so this is minus a will be plus a. So this value will be shifted to here, plus a. And the corresponding all the value will shift to plus value. So you will get some plus value here up to t naught. So please consider, check this one and this one. Both signals are same. No? So here in this case, xt is equal to minus x minus t. In other words, minus xt is equal to x minus t. So this is a odd signal. Okay, this is odd signal. Okay, so I hope you can understand what is even and odd signals. So the important thing is any signal, any xt signal, we can express as even and odd component. So any signal has a even component and odd component. So that signal will be a collection of that even signal and odd signal. So this identity you have to keep in mind. Any signal can be expressed using the even terms and odd terms. Okay. So if you want to find the even signals of any signal, so you can get half xt plus x minus t. Okay. So this is the even component of any signal of any xt. And odd component of any signal, you will get half xt minus x minus t. So this will be your odd component. Okay. So you have to keep remember these three identities. Okay. One more two question will come from these three identities. So you have to keep remember. Okay. So sometime I may have given this equation for the exam. Okay. So you have to understand how to apply this equation when we are analyzing a signal. Okay, that is the more important thing. Okay, so if you can't keep remember this identity, I can give you. Okay, but try to keep this in remember. Okay, then you can do the calculation fastly. Okay, so please keep this remember. Please keep remembering these three identity. Okay, so that is any signal can be expressed as odd and even component. Okay, any signals or even component can be calculated as xt plus x minus t. divided by 2, and any odd signal of any signal can be evaluated or can be obtained by xt minus x minus t divided by 2. So please keep remember these three identity, and also you have to keep remember the definitions. Okay, these are the definitions. For even signal, x minus t is equal to xt, time reverse signal is equal to the signal is itself. Okay, so for signal x minus t, time reverse signal is equal to minus xt. Okay, so you have to keep these two definition also. Okay, so we will take one more example to understand how to use this equation for analyzing purpose. Okay, so I will get another example. Okay, so this kind of question will come to your exam. Okay, so you have to do this kind of questions definitely. Okay, so for example, let's say we have given a xt signal. Okay, so xt signal is like this. It is like this. Let's say this is 1, and let's say this is 2. Okay, let's say this is 2. Okay, so these are the time value, and this is the amplitude of the signal. So the xt is here. Okay, so we are asked to find, for given xt, we are asked to find odd component and even component and odd component. So how to find this? So how to find this? Okay. Okay. Let's draw the time reverse signal. So I hope you can do it very quickly now. Okay. So if I draw the time reverse signal. Okay. So this is t. This is x minus t. So you know that for x et you can evaluate it through half xt plus x minus t. Okay, and what part you can evaluate through half xt minus x minus t. So through these two identities, equations, you can estimate the even and odd parts. Okay, so you can see that xt is given. To find the even and odd part, you have to find the reversed signal, time reversed signal, time reversal signal. Okay, x minus t. So that is why I am going to draw the minus t, x minus t here. Okay, so if I draw the x minus t here, you know that it is the mirror image of this signal across this y-axis, this axis. Okay, this is the y-axis and y-axis. Okay, so you can see that this is 0 to 1, 2. So you will get like this, 0 to 1. Okay, so this will be 2 and this will be 1. Okay, and then 1 to 2, it is constant value, 1 to 2. Right. So this is the mirror image, no? So if I draw it here, it is like this. No? This is the mirror image. Okay, so I write the mirror image. That means time reverse signal. Now, to find the even parts, I have to add these two signal, no? xt and x minus t, I have to add. So I will add this signal. So what is the adding signal? So if I add these two signal, okay, if I add to this signal, it is a symbol adding, no? Okay, so that is the add. That means xt plus x minus t, that signal I'm going to draw. Okay, xt plus xt. So you can see that here from minus infinity to here 0. and here some minus infinity up to 2 it is 0. So 0 0 it is 0. That means up to 2 the values are 0. Now you can see that 2 to 1 it is 2 and here it is 0. 2 to 1 there is no signal, no xt, there is no signal. This is 2 to 1 0. That means 0 plus 2, that means you will get 2. That means you will get this kind of signal. So what happened 1 to 2? Okay, so 1 to 2, again you have 0 plus this value, these values. So you will get the same value up to here. So this will be 2. Okay, and from 0 to 1 you will get this part like this. This is for 0 to 1. Okay, so this is minus 1, minus 2. Okay, 1, and you will get up to 2. This is 2 also. So this is the xt plus x minus t. Okay, so just add this part here. In this part it is 0. So 0 plus this part. So you will get the same part. And here from 0 to t, this is 0. And 0 plus this terms means you will get exactly this term. Okay. So now this is not the even part. To find the even part, you have to divide this by 2. So I also have to divide this value by 2. So if I divided 2 by 2, you will get 1. Okay, you will get 1 like this. Okay, up to here you will get 1, and this value also will be half. No, so you will get this kind of part. Okay, and this also will be half. That means you will get this kind of section. Okay, so finally for odd signal, okay, for signal, sorry, for even signal xt plus x minus t, x even signal, you will get t. So this is xet even signal, you will get 2 to 1, here also 1 to 2. Okay, now you have from 1. No, so here you have up to here and like this, and here you have up to 1 and like this. This is not up to 1. Okay, this is not up to 2, it is up to 1. So this is the even signal. We have to divide it by 2. Okay, so in the same way, can you find the odd signal? Odd signal you have to subtract. Okay, so what if I subtract? So let's draw. This is t, this is xt minus x minus t. So if I subtract, okay, subtract xt minus x minus t from xt, so that means I will get 0 minus this one. So 0 minus means this all part will be minus, no? So you have to do this question by yourself. Okay, so try to understand this. Okay, if you can't understand, you have to work hard and understand these things. Okay, so this so now you can see that the upper section is like this, no, like this. Okay, so it is 0 minus this part, that means this will be minus. Okay, so actually we get like this. Okay, the actual signal we get is like this. So this is 1, this is 1, and this is 2, and this is 2. This is the actual signal. And if you remove this signal xt minus x minus t, so here it is 0. So this part minus 0. That means you will get the same part, no? This part minus 0, so you will get the same part. So here you will have the same part like this. This is up to 1, and this is up to 2. So you will get this 2. Okay. So this is the xt minus x minus t, but for uh, even parts, for odd parts, you have to divide this by 2. Okay. So if you divided it by 2, okay, divided it by 2, you will get, okay, t x, that is odd function. Okay. So if you divided it by 2, this will be half, no? So this 2 will be 1 minus 1. So you will get like this, minus 1 up to here. And this also 2 will be get plus 1. So you will get up to here like this. Okay. So you have end up with 1. Okay. So this is 1 and this is minus 1. So let's say this is 1, this is 2, and this is 1, this is 2. So this is minus 1, minus 2. Okay. So you will have this kind of up to minus 1. It is 1, then like this. So this is 1. Okay. 1 minus 1. So up to this level, you will get like this. Okay. So this is the odd part. Okay. So this is the odd part. So you know that if we add this to signal, you should be able to get the original signal, because xt is equal to x naught t plus xet, because this is the even part of the xt and this is the odd part of the xt. And if you add the odd part and even part, you will get again the original signal xt. So let's do it. Okay, so please add this together. See what you will get. Okay, so if you add this together, okay, I'm going to add this together. That means I'm going to find xet plus x naught. If I add this together, so you can see that this part minus and this part plus, so that pass and that pass cancel out, so you will get minus 2 to minus 1, 0, no value. Okay, minus 1 to minus 1, you will get 0. Okay, and you can see that this is a plus value and this is a minus values, so that plus value and minus value cancel. So up to here you will get no result. See, and you can see that this is 0, this is 0, so same point is there. Okay, but if you consider this point and this point, you will get the addition of that point. Okay, so if you get this point and this point, you will get the addition. So here 1 and 1, you will get 2 here. So at 1, you will get 2. Okay, so you will get this kind of pulse. Okay, from 1 to 2, here it is 1 and here it is 1. So 1 plus 1, 1 to 2, you will get again 2. Okay, so this is our original signal, no? This is xt. If you compare this one, this blue color one, this one, no? So you can see that by adding the even component and odd component, we can get the original signal again. Okay, so please go through this session and try to do this question by yourself. Okay, and also as exercise, try to evaluate, okay, cos omega naught t, that should be a even signal. Okay, and sine omega naught t, it should be a odd signal. Okay, try to prove this. Cos omega t is a even signal, sine omega 2 is a omega t is a odd signal. Try to understand this. Try to do this. Okay. So I will upload some question to the LMS and you can practice them. Okay. So please do this exercise again. You will get exactly same question for the exam also. So this is very important. You have to go through this and you have to be very good at this. Okay. So under signal classification, finally we have learned three type of signals. No, three type of signal, that is random deterministic, continuous time, discrete time, non-periodic, periodic. Now today we have learned even and not signal. Okay. So thank you.